SIFIS Home intends to design guidelines that help developers to write secure and well-tested software and provide tools to evaluate it. One possible way to evaluate a software is to use continuous integration, a practice for which developers upload their code to a central repository, while the builds and tests are run automatically. The main advantages of continuous integration are to spot and fix bugs quicker and improve software quality. A concrete example in which continuous integration comes handy is that of a developer that has to test his software works for different architectures. Continuous integration allows the tests to be run in parallel and automatically, thus reducing the developer's effort. In SIFIS Home, we detailed how a good continuous integration setup should be, but the process of configuring it is in itself very repetitive and time-consuming. To reduce the effort that developers have to usually put when they need to create a new project and continuous integration scripts, we prepared a tool called SIFIS Generate that generates the bulk of it, at least for some programming languages, those commonly used within the IoT context. Practically, this tool generates new project structures and the respective continuous integration scripts automatically. As programming languages, we currently support C, C++, Java, Rust, Python, and JavaScript. For languages that already implement a way or a command to generate new project structure, the tool generates only continuous integration scripts. In this example, we are showing the creation of a Java project. The project template includes all the directory structure to start a new project, as well as a YAML file containing the continuous integration instructions for GitHub. To show the continuous integration at work, we take an existing project, WebThing Rust, and we will apply our continuous integration scripts. To do that, we first clone the repository, then we create a branch to work on, and we finally replace the existing continuous integration script with ours. So, we first remove the existing continuous integration scripts, and then we run the SIFIS generate command by specifying the Rust template. And this will create a YAML file containing the continuous integration instructions for GitHub. The script has to be slightly customized, so we open it and make the needed changes. We can now commit and push the changes. The push command triggers the continuous integration. And here we can see that the jobs defined within our script are running in parallel on remote servers. The jobs refer to workflows we define within SIFIS Home. We can see that these three jobs, for example, are built in the software and run in unit and integration tests for different architectures. The Clippy Rust format job verifies whether the Rust code is formatted according to style guidelines and checks that it does not contain common bad programming mistakes. If so, the job fails. The code coverage job computes the code coverage, that is the portion of code covered by tests. If the value is less than 60, meaning that less than 60% of the code is covered by tests, the job fails. Then, we have jobs that perform a static and dynamic analysis on the code to spot memory leaks and undefined behaviors. To do this, these jobs use well-known software such as FileGrind, Miri, and others. Finally, we have jobs that perform a weighted code coverage according to novel algorithms we proposed and developed within SIFIS Home.